Hello, dear students. Jai Hind. Very good morning. Welcome back. As you all know, that as far as in chapter number 6, ratio and proportion, the topic of compound interest is concerned, we have already allocated lectures for understanding how to find, as you all know, how to find compound interest, where interest is calculated annually. Then how to find compound interest when interest is calculated, or the another word, calculated or compounded annually. Then we also discussed how to find compound interest when interest is calculated quarterly. Then we also found we have done some example where we have found compound interest when the rate of interest for the successive years were not constant, were varying. Suppose for 2 year, at first year the rate of interest may be 10% and for the next year it is 12%. So that way, such type of example also we have done. And if you remember, in our last lecture, number 11, we have practiced how to find deposited amount, means how to find principal. When you are given amount, when you are given R, rate of interest, when you are given N, number of years. Now see, dear student, in today's lecture number 12, please note what we are targeting. Chapter number 6, that's ratio and proportion. Okay. In today's lecture number 12, okay, we are targeting, in last lecture number 11, we have targeted how to find principal when rest of the physical quantities were given. Now we are targeting some different type of example. Understand? Before start, you all know the formula of amount, that is A equals to P into bracket 1 plus R upon 100 raised to n. When there are few quantities, one is amount, one is principal, one is period, means number of year or month, and one is rate of interest. As you all know, and we have practiced in our previous lecture, that if out of the four quantity mentioned here, if any three are given, we are able to find the fourth quantity by some precise method where you have to follow the similar way. Okay. So now, dear student, in today's lecture, we are practicing some such type of example where you will find number of year. Okay. So first question I am writing here, and then you just try to understand the given data in that particular example. Okay. First let us write the question. Question number 1. What is the question? It is like this: in how many years, note down the question with me, in how many years in how many years rupees in how many years rupees 800 amounts to. Please concentrate on the question. In how many years rupees 800 amounts to amounts to rupees 882 at 5% annum. Annum means annual. As you know, if interest is interest is compounded. I will give time to write down the question properly. Compounded annually. Okay. First, you please note down the given question. Okay. Feel comfort to note down the given question first. Question is in how many years rupees 800 amounts to rupees 882 at 5% annum if interest is compounded annually. First, you need to write the question properly, and then you need to understand the given data and what they are actually conveying. Okay, see, dear student, first very important thing is from the given data itself, you have to mark those important quantities which has been given. In how many years? Rupees 800, that means principal is given. Amounts to rupees 882 means amount is given at 5% rate of interest per annum means rate of interest is given, and at the same time the basic data interest is compounded annually. That is very important to understand. Okay, how can we solve this particular example? First, you just write the given data. Principal P has been given, that is rupees 800. That's the amount deposited is given. Then you are given it amounts to rupees 882, and you are at the same time also given rate of interest, that is 5%. This is the data we can estimate from the given example. In how many year rupees 800, which is the principal, amounts to rupees 882, which is the amount at 5% rate of interest. We are looking for the number of year. Okay, n equal to question mark. Let us first write the basic formula which is given. A equals to, please follow me. I will keep the pace of explanation and writing in such a way that you can follow me. A equals to 1 plus r upon 100 raised to n. Okay, let us substitute the values. What is the amount given? 882. What is the principal which is given? 800. 1 plus what is the rate of interest given 5 upon 100, and n is not given. That's our target. Okay, this is the first step. You should know how to follow the steps with me. A equal to P into 1 plus R upon 100. The basic formula has been written. Then the values are substituted. 882 equals to 800 into bracket 1 plus 5 upon 100 raised to n. Now the next step will be first possible cancellation to be done. 5 1 ja, 5 20 ja. Okay, not only this cancellation, but in the next step you have to bring this number principal here. So this is the next step we are doing. 882 upon 800 equals to 1 plus 1 upon 20 raised to the power of n. Okay, is it clear in your mind? You must have understood the step. This is the only possible cancellation we can do here. 5 1 ja and 5 20 ja, 1 upon 20. Rest of the data, what I have done, I have transferred it here and I have just cancelled this. Now, dear student, next step will be the possible cancellation of 882 and 800. Let us cancel by 2. 2 for 100 ja, 2 for 41 ja. Rest of the cancellation doesn't seem possible here because here units digit is 1, here 0. So you just write it down as it is. Here, dear student, you know the method. Here, if you take 20 as LCM, 20 will multiply with 1. 21 ja, 20 plus 1. Can I write this way? 21 upon 20 raised to the power of n. How I got 21, that you know. 21 ja, 20 plus 1. 21 upon 20. You have done it so many times. Understand? After that, now I need your more concentration here in this type of example. See, dear student, here you made the possible cancellation. Not only that, here you have to take an LCM. Now please try to understand somehow this number will definitely relate to this and this number will definitely relate to this. If you just try to assess out, 400 is the square of 20. 441 is the square of 21. You just see 20 20 ja 400, 21 21 ja 441. This is going to happen permanently in this type of example. This is going to happen. Both the number appearing in numerator and denominator here on the right hand side are somewhere relate to the number present here in numerator and denominator. This is compulsory and this is going to happen every time. So now you know 400 is the square of 20. 441 is the square of 21. So can I write this as 21 square? Yes. Can I write this as 20 square here as it is? Now in numerator and denominator both has common power 2. So by the basic rule of maths, you all know I can write in this way: 21 upon 20 raised to n, and here on right hand side 21 upon 20 raised to n. Now dear student, sorry, here too. Now you compare on both the side, equal to sign, similar base. So power can also be compared. So when you compare the power, you got 2 equals to n, means you got the answer n equal to 2 here. But dear student, just this is not sufficient for you to just write. When you calculate your sum, you have to be precise enough to write the final statement. That what you will write in final statement, I am not just writing here, but you should write this final statement. What you will write: in 2 years, please note it down. In 2 years, rupees 800. Should I speak again? In 2 years, rupees 800 amounts to rupees 882 at 5% annum if interest is compounded annually. This is the way you should also write the last statement. What should be the last statement? In 2 years, rupees 800 amounts to rupees 882 at 5% annum if interest is compounded annually. Is it clear in your mind? Just have a look of just for 1 minute, and then we will shift to another example of the same type. First you should, as I told you in our previous lecture, also in lecture 11, that at that time, if you can remember, I told you when we are looking for principal at that time. So I told you at that time that for finding the principal amount, there occurs a precise method and precise step. So here in this case also, whenever you want to find number of year, you have to be very sure about this way you can express the sum. Understood? Okay. First you verify it, and then we will write one more example here and we'll solve it. Okay. Is it clear in your mind? Letter, okay, you must have written and you must have understood precisely the way the sum can be calculated. You first see this. Understand? Okay. Let us go for next example. Okay. The next one we are targeting now. Next example may vary it in data, but the method will remain the same. Okay. Method will remain the same, though there is some variation you will find in the given data. Variation in given data will not demark the method from its original one. Okay. See, this is the data. Okay. Let me write it here. Sum number 2. Please note down with me in what time. In what time rupees 1200. In what time rupees 1200 amounts to rupees 1200 amounts to rupees 1331 at 5% annum, 5% per annum. Okay, if interest is compounded, if interest is compounded annually. Please first note down the question. This is the question. In what time? That means we are looking for the period, okay? In what time rupees 1200 amounts to rupees 1331 at 5% per annum if interest is compounded annually. Okay, the few words of highlight again. Time, that means you are looking for. Principal has been given 1200. Amount has been given 1331. Rate of interest has been mentioned 5%, and interest is compounded annually. That is also mentioned. Understand? So it becomes little easy for you to formulate the example, not so difficult. Okay? How can you target this? So the first one will be whatever the data is given, please write it down. P, that's equal to rupees 1200. Amount, that equals to rupees 1331. Rate of interest has been given 5%, and n, that is number of years you are looking for. Okay, n is your target, like in previous example. Here also you are targeting n. Okay, so the first one, basic formula, as you know, a equals to p into bracket 1 plus r upon 100 raised to the power n. Then first amount, it has been mentioned 1331. Principal has been mentioned 1200. 1 plus rate of interest is 5. Understand? Upon 100 raised to n. Okay? Right. Now, after writing, amount is given 1331. Oh, sorry, 1323. So sorry. 1323, dear student. Please make a change. Amount is 1323. Okay? 1323. Right. This is the data. Here I should make a change. Amount is 1323. Let us follow the steps as usual and precisely what you have followed in the previous example. This is cancelled. Not only this cancellation, you will bring this here. Okay, So the next step I am writing it here only. 1323 upon 1200 equals to, as you all know here, 1 plus 1 upon 20 raised to the power of n. Next step, dear student, going to be the step of cancellation. As you can understand the steps, cancellation by 2 will never be possible here because the units digit are 3 and 0. So cancellation by 2 is not possible. Then you can see either the cancellation with 3 is possible or not. That you have to see. Is cancellation by 3 seeming appropriate and possible here? Yes. 3 400 ja. 3 441 ja. So now dear student, looking like the previous example, 441 upon 400, which comes out to be 1 plus 1 upon 20 raised to n. Then the next step, 441 upon 400. Here you take the LCM, it will be 21 upon 20 raised to n. Then as I told you in every example, there is always a relation between numerator to numerator as well as denominator to denominator. So it looks like this is a square of this. I can now write directly 21 upon 20 raised to 2. This is 21 upon 20 raised to n. Same base. Equal to sign is suggesting that both the terms are equal. So you can compare the power n equal to 2 here. Okay. And after you get n equal to 2 here, you have to write your last statement, which is that after you get this particular answer, n equals to 2 here, you will write your final statement in this way: in time period of 2 years. This is the way you should write statement: in time period of 2 years, rupees 1200. See, understand this. In time of 2 years, rupees 1200 amounts to rupees 1323 at 5% annum if interest is compounded annually. Okay. So, is it clear? Just have a look at the sum and we'll also solve another example which involves some fractions which may be sometime causing problem for you. So that one more example also we are going to target. Okay. First we just have a look at the example and look at the steps which are involved in this. Okay. Right. Let us take one more example. Okay. One more example. Not down. See, what is the example? Let us write down it here. In what time? This is the question. In what time rupees 64,000? In what time rupees 64,000 amounts to? amounts to rupees 88,360 at 88,360 at 17.5% per annum. 17.5% per annum. Per annum. Per annum means annually. If interest is compounded annually. Okay, please first note down the question. What is the question? In what time rupees 64,000 amounts to rupees 88,360 at 17.5% rate of interest per annum if interest is compounded annually. Okay, first let us write what is given P, that's rupees 64,000. What is given amount rupees 88,360. What is given rate of interest 17.5%. Let us convert it. 17 2 ja 34 plus 1 35 upon 2%. N number of years n you are looking for. Let us write the formula. A equals to P into 1 plus R upon 100 raised to N. Amount 88,360. Principal 64,000. 1 plus, now be precise. R means, see what I am writing here, 35 upon 2 upon 100 raised to the power n. Next step, before cancellation 2 is to be transferred here and this is here. 88,360 upon, let us transfer it, 64,000 equals to 1 plus 2 will be transferred here. So this will be 35 upon 2 into 100 raised to n. Next step, 1 0 can get cancelled here. So 8836 upon 6400 equals to, here whatever the cancellation is possible, 5 7 ja and 5 20 ja. This is the only cancellation possible, so it is looking like 1 plus 7 upon 40. 1 plus 7 upon 40. Okay, 5 7 ja 5 20 ja. 7 upon 40 raised to n. Is it clear? Next, LCM 8836 upon 6400. If you take LCM here, it will be 41 ja 40 plus 7, 47 upon 40 raised to n. And now here the further cancellation start with 2. Okay. So 2 30 to 100 ja. Continue with 2 4 4 1 8. Still continue with 2 to 1600 ja. And here 2 2 2 0 9. Okay. So now you got 2209. Further cancellation doesn't seem possible. Upon 1600 equals to 47 upon 40 raised to n. Now just try your best to relate it. Is it possible to relate? Yes, 1600 is a square of 40. So 2209 is a square of 47. So you can write this way directly, 47 upon 40 raised to 2 equals to 47 upon 40 raised to n. In between there is equal to sign. Base are similar on both the sides. 47 upon 40, 47 upon 40. When base are similar, understand, it is very easy to just compare their power. It's a question of simply comparing the power. So n equal to 2. Understand? 2 here. At the end, when you got this answer n equal to 2 here, you can write the statement like in how much time? So in time period of 2 year, rupees 64,000 amounts to rupees 88,360 at rate 17.5% per annum if interest is compounded annually. You understood this? See, dear student, here there may remain some minor fluctuation, understand, but be very sure that here if the cancellation is possible, till ultimate you have to cancel the term, and once you when feel that now the common cancellation doesn't seem possible, then try to relate this number with the numerator and denominator, which can be visualized on the RHS side. Understand? You will be able to do it very easily. Always, somehow, there must lie the relation between these two. So n equal to 2 here. So your final statement, in time period of 2 year, rupees 64,000 amounts to rupees 88,360 at 5 at 17.5% per annum if interest is compounded annually. Okay, dear students, see, in last lecture we have practiced in lecture number 11 examples to find principle where applies a specific track to follow to find the principle. Here in today's lecture we have practiced how to find number of year. In next lecture you will practice how to find rate of interest. All this, either P, either R or either N, involves some specific type of steps and specific type of precise understanding and method. Then and then you are able to solve such type of example. There must be some relation between LHS and RHS in terms of power, either square, either cube, either 4 power. Okay. So this way, dear student, we have today taken all three example which has been mentioned as a part of exercise and illustration from your textbook. Okay, so practice all these sums thoroughly. More homework will be delivered to you at the end of the lecture. Okay, thank you very much.